the Section 5.4 homework are the odds 3 to 51 that you see here. Let's just talk about the actual instructions. So problems 3 through 13 say to use long division. So please do the division they have required. Problems 15 through 37 are synthetic division. I would like to do problem 37 with you now. So if you could go to problem, or if you want to look at problem 37. The reason I want to do 37 is I know we didn't do one quite exactly like this in the notes. And so I want to do this with you now. So in problem 37, they ask us to use synthetic division on this. The problem with using synthetic division on this problem stems from this right there. The fact that that is has a 2 on it. Synthetic division is made so that it's x plus or minus a number, not 2x. So to fix the problem right off the bat so that we can use synthetic division is we have to divide out the 2. So we're going to have to divide everything here by 2 and everything here by 2. Okay. Whatever the front coefficient on the x is of your divisor. So technically, we're going to do synthetic division to 2x to the 4th plus x cubed minus 2x squared plus x plus 1 divided by x plus a half. So that's the synthetic division we're going to do, because the synthetic division box, it will only work if we do that. Now, you're going to take your x plus 1/2, set it equal to 0 like normal, solve for x. That's what's going to go in our corner. We're going to use the coefficients for here. Now you'll notice the powers are perfect, 4, 3, 2, 1, nothing. So we pull out the coefficients, 2, 1, negative 2, 1, and 1. And we're going to set up our synthetic division box. So our synthetic division actually is going to work out pretty good. We're going to multiply. Negative 1/2 times 2 is negative 1. Write it down. Add them up. Multiply. Write it down. Add them up. Multiply. Write it down. Add them up. Multiply. Write it down. Add them up. So we actually get a 0 remainder, which is great. So they did mention to note what your remainder and what your quotient is. Our quotient is the answer we see here, putting the x's back on. Now remember, we started with an x to the 4th. This is going to become an x cubed. And so our quotient, our answer is 2x cubed plus 0x squared. Now you don't have to put that 0 term if you don't want to, but you can. Minus 2x plus 2. And then since we have that 0 remainder, we don't have any kind of fractional piece at the end. So that is our answer, which is great. It's not a bad answer. Even though we ended up with fractions in there, they usually design them so it still works out pretty good. So that's how you do a synthetic division. If there's a front number on your x of your divisor, you must divide it out first or synthetic division won't work. Okay. Now, going back to the assignment, I want to look at the instructions for the next section.
I'm not done writing that.
I know, I can. So if you go back to the next section, it says for exercises 39, 41, and 43. Let's read those instructions. It says, use synthetic division to determine whether the first expression is a factor of the second. If it is, indicate the factorization. So what we're going to do is, for 39, 41, and 43, we're going to do synthetic division, and if we get a zero remainder, we're going to try to factor it as far as we can. That's the only thing it says. What I want to do is I want to do 45 with you, and that will allow you to try 47 on your own. Okay, so let's take a look at 45. It says,
I wasn't done writing that.
now 45 says that we have a third degree polynomial that's shown, and one factor. And it says we want to write the factor form of the polynomial suggested by the graph. So, and the leading coefficient is 1. So the a value is 1. For all of these, the a value is 1. So let's think about what we know for 45. Because remember, you're only doing the odds. So we'll do 45 together, and then 47, you can try that on your own. For 45, the 0 here is 1. So we know another factor is x minus 1. So we know that x minus 1 and x squared plus 2x plus 4, the one they gave us, are both factors of that polynomial. So if we multiply together, what will our lead term be? It will be an x cubed. And so all we got to do is multiply it, and we have our answer. So the answer, let's multiply, let's distribute. So the x gets multiplied. That's x cubed plus 2x squared plus 4x. Then we're going to distribute the negative 1, which is negative x squared minus 2x minus 4. And then the only thing left for you to do is just make it a little prettier by, let's go ahead and combine like terms, put it in descending order. So we've got x cubed. We've got 2x squared minus x squared is plus x squared. We've got 4x minus 2x, which is plus 2x, and then minus 4. So if you were to put that polynomial into Desmos, it would look like the graph that you see there. Okay? So use the place that you hit the x-axis, your intercept, to find the missing factor, and then multiply it all out to find the polynomial. So that's 45. 47, I want you to try on your own. And then 50, 49 and 51 are the last problems. Let's talk about those. All they want you to do is to do long division. It's just, it looks like a fraction because it's set up like it's the top divided by the bottom. They just want you to do synthetic division. So that's your 5-4 homework. The 5-5 homework is on the page you see here. The assignment is 7 to 45 odd. Okay. So let's start with the instructions for 7 through 13. For these ones here, it says use the remainder theorem to find the remainder. If you were to divide, what would the remainder be? So if we start at number 7, we're going to use an x value of negative 3. Here is the function we want to use. And so all we need to do is plug in f of negative 3. So number 9, you're going to plug in 4. That will be a remainder. Number 11, you're going to plug in 4. That will be a remainder, and so on. So that's all you have to do. They don't want you to do the full division to find the remainder. They just want you to plug it in to find the remainder. Next, the instructions for 15 through 21. For all the following exercises, use the factor theorem to find all the zeros of the given polynomial and one factor. Use the factor theorem to find all zeros for the given polynomial. Okay. So, for 15 through 21, they have given us one of the factors that works. So your job is to remove it. Since these are all cubes, as soon as you do the division and remove it, what's left is a quadratic that can either be factored or you have to use a quadratic formula. Okay, so let's do 15 together. They've told us that x plus 2 is a factor. So remember, x plus 2 equals 0 when x is negative 2. So that's going to go in our corner of our synthetic division box. Look at our coefficients, 3, 2, or I'm sorry, our powers, 3, 2, 1, nothing. They're in perfect order to set up our division box. So 2, 1, negative 5, and 2. Okay. Now that we've set up our division box, let's do the division. Multiply, write it down, add them up. Multiply, write it down, add them up. No, that would be a plus 6. Multiply, write it down, add them up. You should get a remainder of 0 because of the fact they have told you that is a factor that works. Now, what do we know so far? Well, in number 15, we have the x plus 2 that was given, and then we just found that 2x squared minus 3x plus 1 is also in there. Most of the time, but not all of the time, they're going to make that quadratic something that factors further so you can find the zeros. If it factors, I want you to factor it. If it doesn't factor, I want you to use the quadratic formula to find those zeros. This is a factorable quantity. It factors to be 2x minus 1 and x minus 1. Now that's the factored form, but they asked us to find the zeros. So the zeros come by setting each one of those equal to 0. So the zeros are negative 2, positive 1/2, and positive 1. So for 15 through 21, they have given you a factor. Take it out by division, either long division or synthetic, and then break down what you get as far as you possibly can to then find the zeros. If it's an irreducible quadratic that can't factor, I want you to use the quadratic formula. Next, for problems 23 through 39. For those ones, they say in the instructions to use the rational zero theorem to find all the zeros. So you notice that this function is equal to 0, so they're just telling you to solve that equation. Where is that function equal to 0? So I would like to do with you problem 23. Let's do 23 together. Let me take a little screenshot of 23. Okay, let's look. So what does it say? Well, I would start out doing the P's and Q's with this one. Our P's are all the numbers that go into 24. There's lots of them. Plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. I think I got them all, but if there's something I have missed, please let me know. The Q's are all the numbers that divide into 2. So that's just plus or minus 1 and plus or minus 2. We're going to take that list and divide it by 1 to make the P over Q's, which is just the list. And then we're going to divide the list by 2. Now, when we divide the list by 2, the even ones are going to be there, but the odd ones aren't. So we can add 1/2 to the list and 3/2 to the list. I don't think anything else. So all the P's over Q's are listed for you right here. That means if there is a rational root in there hiding, it's on that list. So it's just our job to try any of the things on that list. So my suggestion would be start with 1. Okay, so I'm going to call this thing right here f of x. If I plug in 1, I get 2 plus 7 minus 10 minus 24, not 0. So nope, 1's off the list. So then I'm going to plug in -1. I'm going to get -2 plus 7 plus 10 minus 24. Still don't get 0. Nope. Now I'm going to try 2. I think 2, well, let's see, maybe. Okay, 2 times 8 is 16. 4 times 7 is 28. And that's minus 20 and minus 24. And that might have got it. Let's see. 16 plus 28 minus 20 minus 24. Oh, it's 0. Yay. So as soon as you find one that gives you 0, bam, you're done. Oop, great. What does that mean? Well, that means that x minus 2 is a factor that can be evenly divided out. So let's divide it. Now you can use long division or synthetic division, whichever division you want. I tend to go with synthetic. I'm going to put that 2, that was our 0, in the corner of our f of x, which has coefficients 2, 7, -10, -24, and I'm going to do my synthetic division. So multiply, write it down, add them up. Multiply, write it down, add them up. Multiply, write it down, add them up. We better get a 0 remainder because we found it was a 0. So what do we know about f of x so far? F of x is x minus 2, the factor that we took out, times 2x squared plus 11x plus 12. Is 2x squared plus 11x plus 12 factorable? It sure is. Let's talk about how. 2x squared plus 11x plus 12 is a great candidate for slide and divide. So if we slide over the x, that's 24. What are the factors of 24 that add up to 11? Well, 8 and 3. But we slid over a 2, so we got to divide by 2. So that actually factors into 3 nice pieces, x plus 4 and 2x plus 3. But the question, the instructions, and I'll come right back to this, the instructions say to find all of the zeros. Those are the factors. Those aren't the zeros. But we're almost there. The zeros are when those factors equal 0. So that would be when x equals 2, when x equals -4, and when x equals -3/2. So those will be your longest problems because there's lots of things you have to do. So that's what you want to do for that 23 through 39 section. Now, the last part of your assignment is problems 41, 43, and 45. You notice how that one says to find all the complex solutions, real and non-real. What that means is you're going to get a quadratic that can't factor. So to solve that quadratic, and get those non-real i's and funky solutions, you have to use the quadratic formula. Let me write it down for you. Write this down if you haven't already. That's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. So for 41, 43, and 45, most likely you're going to find one zero that's very nice. You'll be able to take that one out. And then what's left is unfactorable. Don't stop there. Use the quadratic formula to find those last two zeros. And then, so there's only 3 of those like that. So let's actually look at problem 41. So let me cut that, paste that down here. So we're going to start out exactly like the section before. You know, look at your back numbers. The p's are, everything goes into 26, and the q is just 1. So p over q's for this is just going to be plus or minus 1, 2, 13, and 26. So there aren't a lot of things that are going to work nicely as far as rational numbers. So start plugging them in. So our f of x is the quadratic, the cubic that you see here. So let's plug in 1. 1 gives us 1 minus 8 plus 25 minus 26, which is negative 8. Nope. So then try negative 1. It's going to be negative 1 minus 8 minus 25 minus 26. Do you see how that gave us lots of negatives? So on that list, I would only start trying positives. Let's try 2. Maybe 2 will do it. 2. That's going to give us 8 minus 8 times 4 plus 25 times 2 minus 26. Let me do that again. 8 minus 8 times 4 plus 25 times 2 minus 26. Oh, it's 0. That's great. Originally, my calculator said 480, and I'm like, that's not right. Okay, so what does that mean? Well, that means that x minus 2 is a factor that I can remove. So let's remove it. 2 in the corner. Set it in synthetic division box. 1, negative 8, 25, negative 26. Multiply, write it down, add them up. Multiply, write it down, add them up. Multiply, write it down, add them up. So this is now x squared minus 6x plus 13. X squared minus 6x plus 13 is an unfactorable quantity. So that means that our solutions, if we were to use the quadratic formula, will either contain just yucky square roots or square roots with i's in them. So it's either irrational or it's imaginary. So let's find them. So we know x minus 2 gave us a 0 of 2. The quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a, is going to give us the last 2 zeros that are missing. Remember, it's a cubic, so we should find 3 zeros. So it's going to be the opposite of b, plus or minus the square root of b squared, minus 4 times a, which is 1, times c, which is 13, is negative 52. See how we got a negative? Over 2a's, which is 2. That's 6 plus or minus the square root of negative 16 over 2. Now, the negative part of things is going to give us an I. The 16 is going to give us the square root of 16, or 4. So this is going to give us 6 plus or minus 4i over 2. Now, many times when I say the quadratic, or when math teachers say the quadratic formula, they say all over 2a. And they say that to remind you that whatever's in the denominator has to divide into both pieces. So I have to divide the 6 by 2, but also the 4. So if one of the pieces were not divisible, I would leave it, but they can. So the final answer is 3 plus or minus 2i. So the zeros, or the solutions, are 2 and then 3 plus or minus 2i. Okay, so there's 41.